Yeah, good afternoon, students. Good afternoon to one and all. So am I visible and audible to all of you? Yes. Okay. Okay. So let's start with the today's class. So in the last class, we were dealing with the thermochemistry part of thermodynamics, right? So yeah, good afternoon, Hashira. Good afternoon. Fine. So in the last class, we have dealt with the thermochemical equations and Hess law, and we were discussing about some formulas in thermochemistry, right? So today we will continue with the thermochemistry, the remaining part of thermochemistry, and then we will go on to the spontaneity and the last topic, that is Gibbs free energy. Okay. So in thermochemistry, we are going to see lattice energy and hydration enthalpy as a first topic for today's session. Okay. So let's start with lattice energy. So lattice energy is denoted by the letter delta H, lattice. Okay. So it is the energy required to break 1 mole of solid ionic compound into the 1 mole of ionic compound in solid state to form the free gaseous ion. Okay, suppose if we are taking the sodium chloride, now sodium chloride is present in its solid state. Now we are taking 1 mole of this ionic compound, which is sodium chloride. Okay, now this 1 mole of the substance is breaking down into its constituent cation and anion, but in its gaseous state. Okay, so we need energy to break that NaCl, right? So this is the NaCl. We need energy to break this interaction, ionic interaction. So that energy is called as lattice energy. Okay, here the ions which are there in the lattice, they are breaking down into Na plus and Cl minus in their gaseous form. Okay, and here it is a bond breaking process. It is a bond breaking process. For all bond breaking process, what we have studied, delta H value should be positive. Why it is positive? Because the process is endothermic. Process is endothermic. What is endothermic? When the energy is getting absorbed by the system, we call that as endothermic process. So since bond breaking is an endothermic process, delta H value will be positive. Got it? So any doubt from the lattice energy? Yeah, very good, Hashira. It is the energy absorption process. So that's why it is called as endothermic. So any doubt from the lattice energy? Shall we move on to the next slide? If 1 mole of the solid compound is getting converted into its gaseous anions, then we call that as lattice energy. Good. So let's move on to the next part. Yeah, this is the difference between the energy absorbed process and the energy released process. So if the energy is getting absorbed, it means that 1 mole of the ionic compound gives its constituent gaseous ion. If the gaseous ions gives 1 mole of an ionic compound, then in that case energy will be released. Suppose if gaseous ions like Na plus and Cl minus, if they combine to give NaCl in its gaseous in its solid state, then we call that as energy released process, because here the bond is forming, bond formation. So it is always exothermic in nature, so the energy will be released. And here ionic bonds are broken, bond breaking process, and here the ionic bonds are formed. Ionic bonds are formed. So the example is given here, and here for the energy for the bond breaking process, delta H will be positive, and for bond formation it will be negative. Okay, so this is the difference between an exothermic process and an endothermic process. So here the first case is endothermic, and this is the second case, and this is exothermic in nature. Okay, so this is the difference. Now next we will move on to hydration enthalpy. Shall I move on to the next slide? Have you all noted it down? Yes. Shall I go on to the? Yeah, sure, Hashira. Take your time. Take your time. Just let me know once you are finished. Done with it. Shall I move on? Yes. Okay, okay. So coming to the next topic, it is hydration enthalpy, which is denoted by the letter. No issues, Hashira, no issues. Delta H naught of hydration. So the enthalpy change when 1 mole of a substance or ion is completely hydrated by water. So suppose, for example, if I'm taking the sodium ion, sodium cation, so now it is in 1 mole. Okay. And here X moles of water is reacting with this sodium ion. And this sodium ion, which is in gaseous state, it is getting converted into its aqueous state. For example, we are taking this ion and X moles of water molecule, which has both positive end and negative end, surrounding that ion. Mostly for H2O, oxygen is the positive end and hydrogen is the oxygen is the negative end and hydrogen is the positive end. Okay, so partially positive for hydrogen and negative for oxygen. So the negative end of this water molecule will come and interact with the cation, sodium cation, and that's how they have formed this bond. That's how the bond is being formed for this cation and the water molecule. Okay. Now this ion is called as hydrated ion or aqueous ion. Because the water molecules are surrounding this, we call that as hydrated ion. And here bond is formed between the water molecule and the sodium ion. So bond formation means what it is? It is exothermic process, right? So that's why delta H value is negative. Delta H value is coming out to be minus 406 kilojoule per mole for this sodium. Yeah, very good. It is negative. So the enthalpy change when 1 mole of the substance or ion is completely hydrated, is completely surrounded by the water molecule. And in that case, bond is formed between the water molecule and the ion. Since bond formation is exothermic in nature, delta H value will be negative. Okay. So this is hydration enthalpy. Any doubt from this? Shall we move on to the next topic? So this is about the lattice energy and hydration energy. Okay. So now let's move on to, enthalpy of solution. So we have one formula to find out the enthalpy of solution. That formula is delta H naught of solution is equal to lattice energy plus hydration energy. Lattice energy plus hydration energy will give you the enthalpy of solvation. Okay. And the solubility of the ionic compound decreases with increase in lattice enthalpy and solubility increases with increase in hydration energy. So here solubility is directly proportional to hydration enthalpy and the solubility is inversely proportional to lattice enthalpy. It is inversely proportional to lattice enthalpy. If the lattice enthalpy is more, then the solubility is very less. If the hydration enthalpy is more, then the solubility is also more. Okay. So these are the two relations which you have to, which we have to use to find out the solubility of an ionic compound, or this can be called as a criteria. Okay. In terms of lattice energy and hydration energy. Clear? So now we will move on with the fourth topic of this thermochemistry part, and that is entropy versus spontaneity. Entropy versus spontaneity. So before moving on to the entropy term, we will first look into the spontaneity term. Okay. So what is meant by spontaneous, or what is a spontaneous process, or what is spontaneity? The process which does not need any help of external agency is called as spontaneous process. Suppose, for example, two examples are given to you on the screen. So let me take the first example. So we have an object A and an object B. Object A is a hot object and object B is a cold object. If I bring these two objects in contact with each other, what happens? Automatically, the heat will flow from the hotter object to the colder object, right? So automatically the heat will flow from hot to cold object. So there is no external agency required for the system. So automatically the reaction is happening. The process is happening on its own. So those processes are called as spontaneous. Spontaneous in the sense continuous process. Okay. And one more example, water flows down the hill. So water is coming from the top to the hill. Okay. Water flows down the hill. And in this case, I am not pulling this water each and every time. It automatically falling down. It's automatically falling down. So it is a spontaneous process. So the spontaneous reaction cannot be reversed without the help of external agency. If there is no external agency, then this spontaneous reaction cannot be reversed. Okay. Suppose if I take this first example, now the whole AB, the whole object is uniformly, they are maintaining a particular temperature. Okay. Suppose let me take, now it is in 50 degrees Celsius. Okay. If I didn't cool this or if I didn't separate these blocks with each other, the temperature will not be reduced. Temperature will not be reduced. So it needs some external agency for the spontaneous reaction to get reversed. Okay. So this is about the spontaneous process. And every system, if you see, they try to reduce its energy in order to gain the stability. Stability is inversely proportional to the energy of the system, right? If the energy of the system is very less, then the stability is more. If the energy is more, then the particular compound is least stable. So what does the criteria for a compound to be more stable or for the process to be more stable? Energy of the system should be very, very less. Okay, this is the first criteria. Now coming to the entropy. Entropy is denoted by the letter S. Entropy is denoted by the letter S. It is the measure of degree of disorderness or randomness in a system. It is a measure of degree of disorderness or randomness. So in the three cases are given to us, and in the first case, if you see, this is solid. Okay. Now this is in the liquid state and this is the gaseous state. Let me take like this. Okay. If the compound, if the system is solid, then the arrangement of atoms will be regular. Arrangement of atoms will be regular and it is more ordered. If it is more ordered, then the randomness is very less, right? They are arranged in a regular pattern. They are not randomly arranged. Okay, the orderedness is more, means the disorderness is very less. If the disorderness is very less, then the entropy is also very less, because entropy is directly proportional to the randomness or disorderness, right? Randomness is very less, so entropy is also very less. That's why the solid state system, they are having very less entropy. Coming to liquid, the arrangement of ions or the atoms, if you see, they will be little bit randomly arranged. They are neither more ordered nor less ordered. So they are in the medium. So the entropy is also in the medium state between the solid and the gas. Coming to the gaseous form, the ions or the molecules, if you see, or the atoms, if you see, they are just randomly moving here and there for the gas, right? So their randomness is very high, or we can say it is less ordered. So the entropy is very, very high. Entropy is more. Okay. So it is a measure of degree of randomness or disorderness. In case of solid, liquid and gas, gas will have the highest entropy value, and then liquid, and then solid. Okay. So this is entropy. Entropy means randomness. Now let us see some of the additional properties of this entropy. Okay. Has everyone got clear with the entropy? Any doubt from the definition of entropy for anyone? If it is clear, just give me a thumbs up. Or if you're having any doubt, just let me ask in the chat box. Shall I move on to the next slide? Shall we see the properties of entropy? Are you guys ready? Entropy is very important. Entropy is very, very important. Okay, just concentrate on. Okay, I'll move. So these are the properties. First of all, it is a state function. Yeah, thank you so much, students, for your response. So it is a state function. Means entropy depends only on the initial state and the final state of the reaction or the system. Okay, and it is an extensive property. What is meant by extensive property? The value changes on changing the size of the system. So entropy changes if you change the size of the system. So it is an extensive property. And coming to the entropy of the solid, liquid and gas, the previous slide only we have seen, right? Entropy of a gas is more. If the entropy is more, then the change in entropy, delta S, is also more for gas. Then comes the liquid, and then coming to the solid. Okay. Now, since it is an extensive property, it is a state function, the delta S naught of the reaction, that is the standard change in entropy of the reaction, can be calculated using this formula. This formula is very, very important. It is equal to the summation of delta S naught of product minus the summation of delta S naught of the reactant. So if we want to find out the standard entropy change for the reaction, then we have to do product minus reactant. Delta S naught of product minus delta S naught of reactant formula. Okay. These are the very important three properties of entropy and one very important formula of entropy. And some more formulas also we have. If you guys have completed this, then we can move on to that. Shall I move on to the next slide? Yes. Okay. So coming to the next point. Yeah. Okay. So entropy. So entropy can be calculated using the enthalpy or heat and temperature. Okay. If we know these two, we can find out the change in entropy using this formula. Delta S is equal to Q of the reversible process divided by T. Q is nothing but heat, right? And T is the temperature. So delta, this delta denotes the large change. If I put D, it denotes the small change. So the small change in entropy, that is ds, is equal to the small change in this heat divided by temperature. So ds is equal to dq divided by T. Okay. Again, this formula is very, very important. You have to note it down, both the formulas. Okay. Now the total entropy change, system plus surrounding is equal to universe, right? Now, if I want to find out the change in entropy of the universe, then I have to sum up the entropy of system and the surrounding. So, delta S universe is equal to delta S system plus delta S of surrounding. Okay. This is another important formula we have to study under this entropy term. Got it? Now, with this information, we will move on to the entropy versus spontaneity, which is nothing but the second law of thermodynamics. Okay. So we have two systems. One is gas A and the another one is gas B. If I mix both the gases with each other, I will get a mixture of this A and B. Now in this mixture, the randomness increases because the space is more. The movement of the gas molecules will be more. So they will be moving in a randomly manner, right? So randomness increases. If the randomness increases, entropy also increases. And this is called as the second law of thermodynamics. This is called as the second law of thermodynamics. Entropy of the universe increases. That is delta S universe is greater than 0. So this is your second law of thermodynamics. Okay. Clear for all? What is first law? What is first law of thermodynamics? Delta U is equal to Q plus W. This is first law of thermodynamics. Now delta S greater than 0, total entropy or the universe entropy, change in entropy is greater than 0 is the second law of thermodynamics. Okay. Fine. Now let's see one more formula. Yeah, this was the formula that we have seen just before few minutes. And we have two different processes, reversible and irreversible. If the process is reversible, then the universe change in entropy is equal to 0. Means it is applicable only for irreversible. If the process is irreversible, then only the change in entropy of the universe will be greater than 0. Okay, for reversible process it is equal to 0, and only for irreversible process the change in entropy of the universe is greater than 0. These are the very, very important points. You have to note it down and you have to keep in mind and study. Got it? So this is about the entropy. So this is one of the formula, and delta S is equal to Q by T. That is the another formula. And for irreversible process, delta S is greater than 0. This is the third relation that you have to keep in mind about the spontaneity or entropy or second law of thermodynamics. Clear? Is this clear for all? Shall we go on with the last topic of this lesson? Yeah. The next topic is Gibbs free energy. Gibbs free energy is denoted by the letter G. Okay, it is denoted by the letter G. Yeah. And we have some properties. So the thing is it is also one of the property of the system. Gibbs free energy is also one of the property of the system. Okay. And it is a state function which depends only on the initial state and final state. Okay. And also it is an extensive property. What is an extensive property? The value changes on changing the size of the system. Got it? And we have a relation also. G is equal to H minus Ts. This relation is very important. So we cannot calculate the directly this G. We can calculate only delta G. So we will get one more formula which is delta G is equal to delta H minus T delta S. So this is one of the very important formula. The upcoming slides also. So this is the formula here. The temperature is constant. So that's why we did not use the delta symbol over there. And coming to the last relation to find out the delta G naught of reaction, that is standard Gibbs free energy change of the reaction can be calculated using the summation of delta G naught of product minus the summation of delta G naught of the reactant. Okay, same as with the case of entropy. The same thing, product minus reactant. Product minus reactant. Very important. Okay, very important. Only in this thermochemistry part, we will have this kind of relation. H naught of the reaction, delta S naught of the reaction, delta G naught of the reaction. Okay. So in thermochemistry, we will have such relation, but they are very, very easy. Only we have to just do addition and subtraction in all these cases. Otherwise, the problem is going to be very easy. We will also solve some problems related to this. Okay. So you don't have to worry about it. I will tell you how to apply these formulas into the question. Fine. Shall we move on to the next slide? We will start with this formula. Delta G is equal to, delta H minus T delta S. So this was the formula which I was talking about. Very important formula which I was talking about. Now we have three processes. One is spontaneous, equilibrium, and non-spontaneous. If the process has to be spontaneous, then it is very, very compulsory or it is needed that delta G should be less than 0. For all spontaneous process, delta G will be less than 0. That is, delta G will be negative. Okay. And for all non-spontaneous process, delta G will be greater than 0. That is positive. And for equilibrium process, delta G is equal to 0. If a process has to be spontaneous in nature, then it is very, very important that delta G value should be negative. Okay. So these are the very important conditions you need to know about the process and the Gibbs free energy change. Okay. Now I will go on with one more slide. Yeah. Now, here, if the process is non-spontaneous, I told you, if delta G is equal to positive, then the process is non-spontaneous. If it is negative, then the process is spontaneous. It can be positive or negative, depending upon this symbol. This can be positive or negative. So if it is positive, then the reaction is non-spontaneous. If it is negative, then only the reaction is spontaneous. If the reaction has to be spontaneous, then the temperature should be very, very less. And only at low temperature, the reaction will be spontaneous if these terms are minus and plus. Okay. And for the next condition, only at a high temperature, the reaction is spontaneous if delta S is positive and delta H is positive. If both are negative, if both delta H and delta S are negative, then at low temperature itself, the reaction is spontaneous. If both are positive, then only at very high temperature, the reaction is spontaneous. For all spontaneous reaction, delta G value should be negative. Okay. So this tabular column, you have to study. There is no other way. Okay, you have to study this table and column. You should know when the reaction is spontaneous and when it is not spontaneous and when it is zero. Okay, fine. Shall I move on to the next slide, which relates, which relates the Gibbs free energy, and equilibrium constant. What is equilibrium constant? KEQ, right? Gibbs free energy is delta G and equilibrium constant is KEQ. Now we will see one relation which relates these two. So suppose I'm having a reaction with A moles of A and it is in equilibrium with B moles of B. And for this reaction, if I want to calculate the delta GR value, then it is equal to delta GR naught plus RT ln2, where this Q is the reaction quotient, product by reactant raised to the stoichiometric coefficient. Okay, now at equilibrium, delta G value will be equal to 0. Now, if I substitute delta G is equal to 0 in this equation, what I will get? And at equilibrium, reaction quotient, that will be equal to equilibrium constant KEQ. Now, if I substitute these two in this equation, what will I get? I will get 0 in place of delta GR, which is equal to delta GR naught plus RT ln. Now, in place of Q, I have to substitute KEQ. Okay. Now, take this plus RT ln Q to the other side, you will get minus RT ln logarithmic function of this equilibrium constant. And if I want to convert this ln to log, what I have to do? I have to multiply by the number 2.303. So that's what we have done here to convert this ln to log. So delta G is equal to minus 2.303 RT log of KEQ. So this relation is very, very, very important. Okay, to find out the equilibrium constant or to find out the delta GR naught in terms of this equilibrium constant, we have to use this relation. Okay, there is only one relation which relates these two. Clear? So with this, the lesson gets over for us. Thermodynamics lesson is getting over with this. Now, we will solve some previous year's questions of JEE and NEET based on this thermochemistry topic. Shall we go with the question? So any doubt from the theory part for anyone? Is everything clear to all? Yeah. So let's start with the first. Consider the following reaction. 2H2 plus O2 giving 2H2O. And the delta HR naught. Standard enthalpy change of the reaction is equal to minus 483.64 kilojoule. What is the enthalpy change for decomposition of 1 mole of water? We have to find out the enthalpy change only. Delta H only we have to find out. But we have to find out for the decomposition of 1 mole of water. So let me write that equation. First, let me reverse this equation. If I reverse this equation, what I will get? 2H2O giving 2H2 plus O2, right? Now, since I have reversed this equation, I have to change this minus symbol to plus. I have reversed this, no? So, it will be delta HR naught is equal to plus 483.64 kilojoule. Okay? So, this is the delta H value. Now, we have to find for 1 mole of water, right? Here the decomposition is for 2 mole. Now, if I have to convert this to 1 mole, what I have to do? I have to divide the whole equation by 2. If I divide by 2, what I will get? I will get 1 mole of water here and 1 mole of hydrogen and 1 by 2 of oxygen. So, since I have divided this equation by 2, I have to divide this delta HR naught value also by 2. So, it is plus 483.64 by 2 kilojoule. Okay. Now, if I divide these two, what I will get? I will get delta HR naught is equal to plus 241.82 kilojoule. So, where it is given? So, the correct answer is option B. Clear for all? Any doubt from this? So, if you are reversing a reaction, then change the symbol of the energy enthalpy term Then if you are dividing or multiplying, do accordingly. Okay. Since we are dividing here, I have divided the delta H value by 2. If you are multiplying, multiply by 2. Okay. So any doubt from this? Shall I move on to the next question? Are you all ready to solve the next question? Say yes or no. Am I audible? Yes. Okay. The equilibrium concentration of the species in the reaction A plus B giving C plus D are 2, 3, 10 and 6 mole per liter respectively at 300 Kelvin. Now the delta G naught for the reaction is, R value is also given. So what we have to find out? Delta G naught we have to find out. Temperature is given. Equilibrium concentrations are given. That is that equilibrium concentration means that concentration terms of all the species are given and R value is also given. We have to find out delta G naught. Which relation we have to use? Delta G naught is equal to the last relation which we have seen, that we have to use, minus 2.303 into RT logarithmic function of KEQ, right? So what is equilibrium constant? How to write equilibrium constant? It is nothing but the product of the product concentration divided by the product of the reactants concentration. This is KEQ. Now substitute this value. Correct answer is option 2. Very good, Ritvik Reddy. Your answer is correct. So let me solve for others also, okay, so that others can understand. So just substitute the values here. So substitute the values here. Okay, let me do it so quickly. 2.303, R value is 2, temperature is 300 into log of, what is the concentration of C? It is 10, and for D it is 6, for A it is 2, and for B it is 3. Now cancel this, 2 gets cancelled. Now here we are having log 10 is equal to 1. Okay, now just multiply this, 2.303 into 2 into 300 is 600, which will be equal to minus 1381.8 calorie as the delta G naught value for this reaction. Okay, direct substitution of the formula. Just you need to identify the terms that are being given in the question. So the correct answer is option B. Correct answer is option B. Is this clear for all? Shall we move on to the next question? Shall we move on with the next question? Yes or no? Students? Okay. The next question, third question says that for irreversible expansion of an ideal gas under isothermal condition, the correct option is. So can anyone try the answer for this question? Irreversible expansion and isothermal condition. What is isothermal? Isothermal means temperature is constant. Temperature is constant means what? Delta T will be equal to 0. And the process is irreversible. If the process is irreversible, then it says, yes, Valmiki, your answer is exactly correct. It is option D. Yeah, good. For irreversible, all the irreversible process, if you see, they will be spontaneous. Irreversible processes are spontaneous in nature. And if the process is spontaneous, what we have studied, delta G will be negative, means delta S value, delta S will be greater than 0. The process is spontaneous or for irreversible process, the total entropy change of the universe will be greater than 0, right? So if it is greater than 0, then it is not equal to 0. So either option C or D should be the correct answer. Now if we want to check for delta U, we know that delta U is equal to NCV delta D, right? So this was a relation which we have discussed in the previous class. In thermodynamics part, we have discussed this. So here delta T goes to 0. So 0 into anything is 0. So delta U is also 0. So the correct answer is option D. Okay. Very simple and it is very easy. You just need to understand it. Okay. Understand the question. Conceptual understanding is very, very important. You don't have to get scared about this type of physical chemistry questions. Okay. Just understand it. Then it is going to be easy only. Shall I move on to the next question? Are you all ready? Any doubt from this? Okay. Hydrolysis of sucrose is given by the following reaction. Sucrose plus water is in equilibrium with fructose and glucose. If the equilibrium constant Kc is this, at this particular temperature, actually it is not 800, okay? It is actually 300. The value of delta GR naught at the same temperature will be. Can anyone try for this? All of you can try. All of you can try. It is just the direct substitution into the formula. Just let me know the answer in the chat box. I will give you some time. I will give you some 15 seconds to solve this question. Direct substitution only. Nothing to do with the mathematics. Can anyone give me the answer? Correct answer? Using the correct relation? Option 4. Very good. Very good. Good. So which relation we have to use? Delta GR naught is equal to minus RT ln KEQ. That's all, right? So delta GR naught is equal to minus R value is 8.314 and the temperature is 300 into ln equilibrium constant is 2 into 10 power 13. 2 into 10 to the power 13. So this is given in option 4. Okay, all these are logarithmic function. Ln. Ln. Okay. So option 4 is the correct answer. Good. Coming to the next question. For the reaction 2Cl giving Cl2, the correct option is. Try for this also. Here, two chlorine atoms in gaseous form are combining to form one chlorine molecule. One chlorine molecule. So, it is the bond formation process. It is bond formation process between the two chlorine atoms. So, bond formation means what is the name of the process? It is exothermic or endothermic? Bond formation is exothermic or endothermic? Give me the answer. No. Bond formation is exothermic or endothermic? Bond formation. Unfortunately, Ritvik answer is wrong for this. No issues. My dear, you can try for the correct answer. Valmiki has given me the correct answer. Option C is correct. Now, you guys tell me whether bond formation is exothermic or endothermic. Yeah, very good. It is exothermic. If it is exothermic, then the delta H value should be negative, right? It should be negative. Negative means what is the meaning? Delta H is less than 0. Delta H is less than 0. So option A cannot be the correct answer, no? So it is less than 0. So option B or C. Only the correct answer lies in those two. Then if you see here, the two particle is getting converted to one. Two atom is getting converted to one molecule. So the number of particles, if you see, is decreasing. Number of particles decreases. If the number of particles or the number of moles decreases, then the delta S will also decrease. If it decreases, then it will be negative, right? If it is negative, it is less than 0. If it is negative, it is less than 0, like this delta H. So option C is the correct answer. Option C is the correct answer. Clear for all? So with the same concept, we will solve one more question also. Yeah, in which case the change in entropy is negative. In which case, 4 options are given, in which case the change in entropy is negative. Try for this. First is sublimation of solid to gas. Solid is getting converted to gas. Yeah, correct answer is option 2. So if solid is getting converted to gas, randomness increases. If randomness increases, then entropy should also increase. If entropy is increasing, then the change in entropy value should be positive, right? But in the question, what they are asking, find out the case in which change in entropy is negative. So here the change in entropy will be positive. So option A cannot be the correct answer. And here if you see the 2 particles getting converted to 1. So I told you, right? So if the number of particles decreases, then delta S value will also decrease. That is negative. So option B is the correct answer. Evaporation of water means already water is in liquid state. Liquid is getting converted to gaseous form. So here also again liquid to gas. Randomness increases, entropy increases. So it should be positive. Okay, it should be positive. So C or D, expansion of a gas, no, that is also cannot be the answer. Expansion. Randomness will increase if it is expanding because the volume will increase, right? So the correct answer is option B. Correct answer is option B. Clear? Also, you can deal this with the bond formation concept also. Bond formation is exothermic. So it is delta H will be negative. Obviously, delta S will also be negative there. Okay? Fine. Any doubt from this question? It's very easy. We will move on with one more question. For a given reaction, delta H and delta S is given. Delta H is given in terms of kilojoule per mole and delta S is given in terms of joule per Kelvin per mole. So we have to be very careful with the units, especially for physical chemistry questions. So just be careful in that. And the reaction is spontaneous at. The reaction is spontaneous at. When will the reaction be spontaneous? So we have to start from the spontaneous condition. For a spontaneous reaction, delta G value should be less than 0. I told you, right? The reaction has to be spontaneous, then the delta G value should be negative. It should be less than 0. So we know that delta G is equal to delta H minus T delta S, right? Both are equal. Now, if delta G has to be less than 0, then this whole term should also be less than 0, right? What does this indicate? Delta H minus T delta S should also be less than 0. Now, from this, what is T? T will be greater than delta H by delta S. Yeah, delta H by delta S. Now, substitute the values. Temperature is greater than, what is delta H? 35.5 kilojoule, right? So, into 10 to the power 3. 10 to the power 3 is nothing but 1000 divided by, what is delta S? 83.6. So, if we solve this, we will get 424. Yes, good, my dear. 424.6, which is approximately equal to 425 Kelvin. Okay, temperature should be greater than 425 Kelvin. Then only the reaction is spontaneous. Okay, on applying the spontaneous condition, using the spontaneous condition, we are arriving at T greater than 425 Kelvin. So option A. Okay, only if the temperature is greater than 425, the reaction is spontaneous. Clear? Fine. Fine. We will move on with one more thing. A2 plus B2 giving 2AB. And for this reaction, the standard enthalpy of formation is given as minus 200 kilojoule per mole. AB, A2 and B2 are diatomic molecule. And if the bond enthalpies of all these 3 molecules are in the ratio 1 is to 0.5 is to 1, then the bond enthalpy of A2 is. So what we have to do? So let me take the bond enthalpies of all these 3 terms as X and here 0.5x and here it is X. Okay, because it is given in that ratio, right? So from this, what is delta HF naught? What is the formula to find out the delta HF naught from the bond energy? It is the summation of bond energies of the reactant minus the summation of bond energy of the product. Okay, this is the formula we have to use. Delta HF is given in the question. Is minus 200, which is equal to, who are the reactants? A2 and B2 are the reactants. And what is their ratio? It is X plus 0.5X minus, and for product it is, for AB it is X, right? And here we have 2 moles of AB. So what we have to do? Substitute 2X. So X plus 0.5X is 1.5X minus 2X, and here it is minus 200. And here what we will get? Minus 200 is equal to minus 0.5X. So minus minus will get cancelled with each other, and X is equal to 200 by 0.5, which will be equal to 400. So what we are getting? X is equal to 400. X is equal to 400. X is the moles of this A2, right? Bond energy is in this term. So the X value is 400. X value is equal to 4. Bond enthalpy of A2 is 400 kilojoule per mole. Is this clear for all? Okay. Shall I go on with the next question? Yes. Yes. Good. Just only one formula we are using in all the questions. So this question doesn't contain options. Why? Because it was asked in JEE. That's why there is no option given here. Okay. So NEET students might be thinking of it. No. Now why there is no option? So in JEE we have some 10 questions which are numerical without option. So it is one of the JEE question. And coming to this question, this question also doesn't contain options, means this is also an JEE question only. The question says that for complete combustion of ethene, the amount of heat produced as measured in bomb calorimeter is 1406 kilojoule per mole. So this is the amount of heat produced from bomb calorimeter. Bomb calorimeter is the instrument which is used to measure the change in the internal energy value. Okay. So the delta U is this at 300 Kelvin. The minimum value of T delta S needed to reach the equilibrium is minus dash kilojoule. R value is given. So how can we calculate? How can we get T delta S? We can use this relation. Delta, we know that delta G is equal to delta H minus T delta S. So this is the relation we know. And in this relation only we have this T delta S term and all. Okay. Clear? And now the question says that T delta S needed to reach equilibrium. For equilibrium process, delta G will be equal to 0. And if delta G goes to 0, delta H is equal to T delta S, right? If we found out this delta H, then it is equal to T delta S. The answer is arrived from that. So to find out this delta H, you have to use delta H is equal to delta U plus delta NGRT formula. Okay. So delta U is given in the question and the heat is produced. Heat is released. So it should be negative. So it is minus 14. Yeah, very good. Minus 1406. Very good, Valmiki. Plus delta Ng. What is delta Ng? Number of moles of gaseous product minus number of moles of gaseous reactant. Who are the product? We have two products, but only one is in gaseous form. We have to take that only. So its number of mole is 2. So 2 minus, and reactant, both the reactant are in gaseous phase, and here 1 mole and here 3 mole. So it is totally 4. 2 minus 4 is minus 2. So substitute minus 2 here, and the R value is given as 8.3. and temperature is given as 300 Kelvin in the question. If you substitute all these things, and also we have to be careful about the unit. R is given in terms of joule per Kelvin. And here delta U is given in terms of kilojoule per Kelvin. So what we have to do? You have to multiply this R by 10 power minus 3 to get the answer in kilojoule. Okay, you have to divide by 1000 actually. So if you divide by 1000, when it goes to the numerator, it becomes 10 power minus 3. So the answer will be minus 1411. Very good. So minus 1406 minus, you will get 4.98 here, which will be approximately equal to minus 1411 kilojoule per mole. Okay. So this is the value for delta H. Since delta H is equal to delta S, the answer is minus 411 kilojoule per mole will be the answer of T delta S. Okay. So I think this is enough for today. It's already 3:57. So we will end up the class here. So I think this session is very useful to all of you. So any doubt any of you have from thermodynamics and thermochemistry lesson? No doubt? Yeah, Hashira, you have raised your hand. If you're having any doubt, just put it in the chat box. No. Okay, no issues. So thank you for listening to today's lecture, and in the next class we will meet up with a new lesson. Okay, we will meet up with a new lesson. So till then, take care. Bye-bye. Solve more questions on thermodynamics topic and come for the next class. Okay. Thank you, students. Thank you. Take care. Bye-bye. Yeah. Which lesson for next session? It is equilibrium. It is equilibrium. Is that okay? Fine. Okay, Valmiki. Bye-bye. Thank you.